Hello, my name is Mark van Gils, and I have started as EAMBES Councillor a bit earlier this year, and I would like to introduce myself, tell a bit about my background, and tell a bit about what my visions for the work in EAMBES are, and hopefully raise interest and set up further cooperations. So my name is Mark van Gils. I'm a professor of digital healthcare at the Tampere University in Finland. So Tampere is a city in the southern part of Finland, which has several universities that have been merged together to one, and it's basically now one big university, and the Faculty of Medicine and Health Technology combines both the clinical research as well as biomedical engineering and healthcare technology, which is my own background as well. So going on in that background, so as I said, my current job is really doing research at the Tampere University, and I'm leading a research group at the moment around 10 people, which is dealing with decision support for health. And I will tell in a moment a bit more about what we mean with that. But if you are interested in learning more about the projects and who the group members are, then this link here might help you. But maybe going back a bit towards my own history, actually I've been working and doing research in biomedical engineering since the very early days of my career, when I was a student in the Netherlands, where I did my master's and PhD at the Technical University of Eindhoven. I did my master's in applied physics, but that actually was also physics applied to monitoring of patient data, already data acquisition of certain brain signals. And after completing my master's at applied physics, I went to the biomedical engineering group where I did my PhD, which in the 90s actually was also when artificial intelligence at that moment was also in some kind of booming phase. So I did my research there at neural networks, applying it to algorithm development for patient monitoring during anesthesia. So trying to figure out if the data that you collect from brain signals during anesthesia, so then basically the time and frequency contents, if you could use that for automatic recognition of for example, depth of anesthesia. So there's actually topics that are relevant today, even still doing pattern recognition on complex health data were already then. Of course, then we have less computing power and less data, but basically the interest was raised, and after that I got involved in an EU project which was led by partners in Finland. Actually, Professor Niilo Saranomi was the main coordinator there, who has of course also had a big role in European research, as we all know, and one of the great members also in EAMBES. So I did there, I moved to Finland, where I did applied technical research at VDT Technical Research Center, where I've been working for quite many years first as researcher and then team leader and eventually as research professor, but always in the field of data analysis related to healthcare. So that's the main theme. And after quite many years actually there, I thought, well, okay, it might be also interesting to change the accent of my work a bit, to go a bit back to academia and work with students to kind of disseminate my knowledge more to the younger generation. So that's why I then started at the Tampere University in 2021, where, as I said, I lead the research group. In parallel with that, I'm also actually linked to Aalto University in Helsinki, or Espoo more exactly, where I'm teaching for almost over 20 years also actually, courses on biomedical signal processing. First there basically as kind of job there dedicated to certain courses, but nowadays we are actually combining courses with Tampere University and Aalto University, so that we have at the same courses students from both universities that are interested in that field. So I mentioned that my research group is dealing with decision support for health, and maybe a bit more exactly what is going on there is that we, of course, as we all know, we have the possibility to collect lots of data from all kinds of devices. So we have, of course, well, I mentioned patient monitors, but we nowadays have all kinds of wearables that you can use at home, or your mobile phone measures everything. We have biobanks, we have patient registries. We have social media, we have all kinds of data that tells us about what is going on with people. The question then, of course, is it's nice to collect lots of data, but that data has, of course, all kinds of noise, and not everything is really valuable or even true. There's many different formats. We have images, we have omics data, we have text data, we have signals. So how actually can we combine that data? And that question is especially then relevant for people that need to make decisions. So doctors or nurses, or maybe people that want to stay healthy, they are in general not biomedical engineers or health data scientists. So the question is, how can we help people that are not engineers, that don't have biomedical engineering education or statistics education, so to help understand what is the main actual contents of that data. So that's where we then come in with our group. We have a very solid knowledge in signal processing, AI, machine learning, not just from a few years, but from decades of years. So we really know what are the merits and what are the advantages and disadvantages of certain types of techniques. And especially we concentrate then on combining those different data sources that I just mentioned, but also really specializing in how to deal with real world data challenges. So it's one thing to do some kind of analysis on a nice data file that you downloaded from the internet, which has clean data and has nice labels. It's another thing to actually measure data in real life with all kinds of missing data gaps, noise, different standards, no idea what actually is the right answer, what is happening in the background of the data. So how to deal with that kind of imperfect data is what we especially work on. So, of course, since we are engineers, we are not doctors, so we kind of have a toolbox with technical tools that we apply to different types of diseases. So we are, as you can call, disease agnostic. So we work with sometimes with cardiac patients, sometimes with neurodegenerative diseases, diabetes patients, Parkinson's. So we have, of course, experience built up over the years in the projects that we are cooperating with new projects or finished project or other types of cooperation projects. So that's really the main things that we are doing, and it's really data analysis, you could say. Of course, as I'm working at the university, education is just an important thing, and I already mentioned a bit that I'm doing teaching and guiding students both at Tampere University here and in Aalto University in Espoo near Helsinki. So it's typically technical students that are interested in biomedical applications, so usually master students or guiding PhD students. And well, linking to my background, it's biomedical signal processing, decision support in healthcare. So what are the merits of using machine learning, AI, for helping doctors to make faster decisions? Behavioral health informatics has more to do with motivating people to understand what they could do to keep on staying healthy or to prevent diseases from happening or from faster recovery. So making lifestyle changes and especially then dealing with the data that you can measure during daily living and not so much in a hospital setting. And then I'm also very active in doctoral seminars for PhD students that want to go further and advance from research to industry. So yeah, so it's very much data science that we are doing, and my group, and also actually we are in Tampere University having a health data science as one of the focus areas at the university, and our research invests in quite a lot. And well, perhaps one reason is that we have quite a lot of data in Finland. So historically, we have actually a unique situation that people in the 1960s already invented that it would be very handy if everybody had a unique identifier that could be used throughout all the lifespans over all the data that is being collected, and actually that has really enabled lots of linking of different data and making different data available. So there's different data sources available that we could use and that we especially then use for preventive care. As I mentioned, people that want to stay healthy and really want to make perhaps changes in their lifestyle. So how can the data serve them to better understand what they should do and what they better not do? Personalized care is a traditional approach where a doctor needs to make decisions and needs to understand what the symptoms mean and needs to understand, okay, what does the MRI image mean combined with this symptom report from a patient and maybe this lab test. So how do we separate and make exact plans for a specific person? That's a very important area. And then healthcare process optimization, in which we are then trying to think about how do we deal with the fact that there are many patients, but healthcare is really under pressure due to the fact that the resources are limited and the population, of course, is getting older, which means that there are many diseases and really many more people to be taken care of. So how can we actually optimize processes? How can we be cost effective? Those type of questions are another topic where my colleagues especially work on at the university here. So this is very much data driven, and as we all know, there's lots of things happening. There's not one day going by that you don't hear that you don't read any news item about AI doing this and making everybody, let's say, unemployed in the future. And there's a lot of things going on, as we know, but and we might be tempted to say, okay, that AI solves everything also in the healthcare domain. And there are clear, nice cases, especially with biomedical image analysis, that show that things are advancing well. But in the general picture, we need to think a bit that actually the uptake of AI or machine learning in healthcare is not so easy. And if you compare it to usage of those type of methods in finance or well, recommendations on kind of services like music streaming or video streaming or travel reservations or all kinds of things where basically AI is used as a matter of routine. In healthcare, it's actually much slower, even if we know that there are huge advantages. And I think that's one of the areas that I would like to help contribute in EAMBES also, because that's one of the research areas that I work in and that perhaps I might be able to help a little bit with. So there, yeah, so you could think about, okay, what is the reason why the healthcare is so difficult for really uptake of AI? And here is a picture that I quite often use, in which I have this type of visualization with some kind of magic AI box in the middle that is supposed to run some computer program that gives some functionality. And traditionally, how we develop those systems is that we have on the left training data as input, and we have on the other side targets. So we have labels. So if you have a simple image classifier, you could have images of cats and dogs on the left-hand side, and then some labels saying this image is a cat and this image is a dog on the right-hand side. And you can develop some classifier that runs in an environment. So a computer with users, it could be an expensive laptop, but it can also be a mobile phone nowadays, much more easily with certain different users. And okay, it runs. And this is a very generic picture, and you might think and argue that if we have a healthcare situation, we have healthcare data and healthcare targets and healthcare environment. And of course, we could have data from a patient, maybe some kind of ECG measurements or lab values or MRI or CT scans. And we have maybe some example data of people that had symptoms related to heart diseases. And then we have knowledge about what happened to those patients. Maybe they got a heart attack or they died at some moment. So we know we can label those data saying, okay, this data that we have here is from a patient that in the end ended up with this or this situation. So there are perhaps targets. And of course, we need to run it in a hospital, maybe with some end users that are maybe nurses or doctors, or maybe we can run it at home for people to use to see what our risks are with then, of course, different types of users. So this is a nice, simple picture, but the problem here is that data, getting healthcare data is already very difficult because we know there are all kinds of permissions for good reasons. That's regulatory issues, but also the fact that the data is often pretty poor quality. It has noise. There is data missing. There's different data formats, so it's really much more difficult than dealing with those examples that I just gave of general applications. Then we have the issue that those targets are usually not so easy to set. Different doctors might have different opinions about what is the disease or what is the diagnosis of a person or what would be the best thing to do for this specific patient. It's all very personalized. The patients are different, so it's a personal recommendation that you need, but also the people that make the decisions might have different opinions. And on top of that, it's not so easy to get some kind of outcomes, some kind of labeled data set, because if you, for example, have data collected from persons in their middle age, then you know only after maybe 10 or 20 years whether they actually got a heart attack. So it's not so easy to just collect example data, because quite often you need to wait to get actually the right answers there. And also the healthcare environment is challenging. It's typically relatively conservative by nature, and there are all kinds of requirements. Of course, again, you deal with patients. It has to do with privacy, security. There's all kinds of legacy systems that have certain formats that are required, also certain standards, how to combine different systems. The staff is, of course, as we know, they are typically very busy or even overloaded. So you cannot really develop some kind of algorithm that requires some kind of difficult user interfaces. So there are many things that actually are on top of that whole implementation that make life much more difficult than just a normal AI that you run in some nice Python toolbox, for example. So these are things that I see that actually are slowing down the uptake of our nice research in practice, and perhaps I could contribute as my counselor role here to help addressing things there. So you could think of the data, advanced access and usage of health data. As I mentioned, there are many issues in getting data in the first place, and we know that there is this legislation. Okay, the famous example of GDPR, which is of course well-meaning and very good implementation, but the problem, for example, is clear that different countries have very different interpretations on how to actually adhere to the GDPR, and if people have been working in EU-level projects, they know that different countries, different lawyers might have pretty different views on what actually is possible and what is not possible. But also there's things being developed, for example, the EU's Act on AI, which actually is requiring all kinds of thoughts and inputs on how to use data. So there's, of course, policy makers, people that are developing laws, but also implementing it in different countries. There's much of things that actually might and do affect the daily life of researchers in this area, that actually we should take the position that we need to influence policymakers there to make choices that are advancing science rather than making things more difficult. So I see that we certainly have a role there. Then in general, the mindset of people that are doing research has been quite often conservative, in the sense that people are collecting data in a study, and they have invested lots of time and money in it, and they are not necessarily eager to share it immediately with others. And this is, of course, a difficult thing, but I think things are going in a better direction there. But still, there is this type of attitude in many cases that's saying, okay, I want to mine your data, but my data is mine. So I think that only can be changed by really working together further and have joint projects in which different partners are working together and see that it's really useful to create extra value. Resources, of course, we can say we need to cooperate and we need to have joint databases. There's really things I would say that we could work together also to concentrate better on joint efforts. So of course the European health data space is one area in which the European Commission is investing, but I think also thinking about smart ways of how to curate the data, how to make sure that it's valid. Providing tools for perhaps younger researchers to better understand what steps you could take and what not take, tools for harmonization, those type of things, make some kind of central repository or area where those tools are available would actually be very, very valuable. Same thing, methods like research, federated learning is a good example where things are happening. I think we also should be able to join those type of efforts. Then the targets that I mentioned that are difficult, outcome impact assessment, there's standardization in dealing with data, but also actually also things that I mentioned here are those OMOP and AIDEN initiatives that actually try to standardize the data. On one place, there is also different initiatives that try to combine the different outcomes of different diseases in a good way. I think there's lots of things there to do, and pretty sure that in almost all countries, people realize that actually impact assessment is important. It's nice to have some kind of classifier that classifies with 90% accuracy some kind of disease, but do people get better of it? Does the healthcare system save costs? How to affect those type of things is more and more important, and we all know that if you write a proposal, then the impact section is very important, which is still one part of the text that not all biomedical engineers equally like writing, and it's also not perhaps the best way of spending competences. So I see that this is really very much let's say need for, again, with cooperation with other disciplines, whether they are not necessarily healthcare sciences, but for example social sciences, if you want to look at social care impact, economics, industrial management, those type of disciplines actually have a long history in trying to figure out on how to optimize processes and how to measure return on investments. And I think we can actually borrow and learn quite a lot from those disciplines. So working together in healthcare technology assessment frameworks, other disciplines, looking at tools that others have developed perhaps in another area than biomedical engineering, and trying to learn from those to make things on our side better. And then finally, looking at the environment, so improve the uptake so that people actually want to use those technologies in the long term, so that it's not only some kind of nice gizmo that some university has developed, but then that stays in the kind of on the table that nobody uses it. So there's one thing that I think we could and should put effort to is really helping to give knowledge to professionals, so doctors, nurses, maybe social care workers also, and patients, to help them better understand what is, let's say, the hype and what is actually advantages of new technology. And then, of course, health tech literacy is a wide concept, but I would then, of course, from my area, I would concentrate on trying to make clear what actually AI and machine learning could do and could not do, and continuing from that, those type of things like explainable AI, trustworthy AI are very important, and actually the European Commission requires that kind of parts nowadays in the let's say high-risk AI implementations. We are also in our university doing a lot of research there on evaluating the explainability and trustworthiness of AI implementation. So we would be very willing to contribute to there. And then, of course, at a very general level, helping again, if you set up any projects, make sure that you involve patients and policymakers and companies, etc., from the very beginning. Of course, this is not a very new thought. It has been around for many years already, but still it's always difficult. And I think we really need people with networks in the different areas to really say, okay, if we have a new project or a new initiative, then we need to involve different people. And of course, that's one of the strengths that we have here now in this organization, that we have councillors and others that are actually very well connected. So combining and contributing their own networks to the overall goal is one thing that is something that we could use further, and that I hope to contribute to that. And that's in a very short nutshell what I had in mind. So I thank you for your attention, and I'm very open to discuss further with you and exchange ideas. And I hope to have a nice cooperation in the coming years. Thank you for your attention.